Okay, this video will cover section 2.6. Problem number 1 asks us to find the slope of the secant line through the points 3f of 3 and x f of x. Now, we do not know f of x. So over here at 3, we're just going to pick a point and we're going to say, well, that's f of 3. This point could be anywhere on the y-axis. And then we have x, right? Just some arbitrary point. We'll call this x, and then there's an f of x here. And they want us to find the slope of this secant line. So we know that the slope of the secant line is going to be given by f of x minus f of 3. That's our y value minus our y value divided by x minus 3. And that's all we can do for problem number 1, part A. We don't have any other information. Now it says, write the expression for the slope of the tangent line at P. So part B wants the slope of the tangent line. Now to get the slope of the tangent line, we're going to have to let x approach 3. So that's going to be the limit as x approaches 3 of f of x minus f of 3 divided by x minus 3. The secant line is just between 2 points. The tangent line is as x approaches 3. So we let the distance between x and 3 get smaller and smaller and smaller. So that's question number 1. The next problem we're assigned is question number 3. So I'll do that one as well. It says find the slope of the tangent line to the parabola. So here they give us our function. We get y equals 4x minus x squared. And they give us the point 1, 3. Part A says, find the slope of the tangent line using definition number 1. Now, definition number 1 is our definition that says the slope of the tangent line is the limit as x approaches a of f of x minus f of a over x minus a. That's the definition. So for us, that's going to be the limit as x approaches our a. Remember, that's a f of a. So our x is going to approach 1, and we're going to have f of x minus f of 1 over x minus 1. And we can substitute in values, right? Because we have a value for f of x. So this is going to be the limit as x approaches 1. F of x is 4 minus x squared minus f of 1. F of 1 is 3. And that's going to give us on the bottom x minus 1. Now, when we simplify that, we get the limit as x approaches 1. That's going to be minus x squared, right? And then 4 take away 3 is plus 1 over x minus 1. Now, we need to factor minus x squared plus 1. The way we're going to factor that, I think the most direct approach would be to factor out a negative 1 and rewrite this as x squared minus 1 over x minus 1. That gets us the limit as x approaches 1 of negative 1. This is going to be x plus 1. This is going to be x minus 1. And on the bottom, we have x minus 1. Now, this x minus 1 will cancel this x minus 1. And we're left finally with the limit as x approaches 1 of negative 1 times x plus 1. We can evaluate that limit by plugging it in. So we get 1 plus 1, that's 2 times negative 1. So we get the slope of our tangent line is negative 2. Now in part A1, it said use that definition. In part A2, it said use equation 2. Now if we look at equation 2, that is the limit as x, whoops, strike that. That's the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, what does that get me? Well, to do this, we have to do a little bit more work, right? We have to find f of x plus h. And in class, I suggested we do this separately. So that's going to be 4 times x plus h minus x plus h squared, right? So we'll do that work over here off to the side. Now, what is that going to be? That's going to be 4x, right? 4 times x plus 4h, we're just distributing, minus, and when we square this, we get x squared plus 2xh plus h squared. Okay, so that's f of x plus h. Now, f of x is right here, 4x minus x squared. So when we plug that in, what is it going to look like? We're going to get the limit as h goes to 0. We're going to get f of x plus h. So we're going to get all of this, right? So what do we have? We have 4x plus 4h. I'm going to distribute here. So I get minus x squared minus 2xh minus h squared, right? Now I have to subtract f of x. All divided by h, okay? So what happens here? Well, let's see if anything cancels. This negative is going to make that 4x negative 4x, but there's a positive 4x. So those go away. This negative is going to make this negative x squared positive x squared, but there's a negative x squared. So those go away. And what are we left with? We're left with the limit as h approaches 0. And we have 4h, right? That's still there. Minus 2xh minus h squared, each of those terms is still there, divided by h. That's going to get us the limit as h goes to 0. We'll factor out an h, and we have 4 minus 2x, right? Oops. Minus h divided by h. Now these h's will cancel. We'll make some room over here. And we have left the limit as h goes to 0 of 4 minus 2x minus h. Now, as h goes to 0, this disappears, and we're left with 4 minus 2x. That's what we get. We get 4 minus 2x. Now, I'm looking back here because I think I might have made a negative sign error somewhere that I'm not really sure about. The graph of 4 minus x squared, if we were just to graph that real quick, right? 4x minus x squared is x times 4 minus x. So we have a 0 here, we have a 0 at 4, and it opens down because the x squared is negative. The 0.13 is right here, so our slope should be positive 2. Somehow over here I got negative 2, which means someplace over here I made a negative sign error, where one of you was probably trying to tell me, Kevin, stop, you made a mistake. Let's see if we can find where I made my mistake over here. Where did I make my mistake? We had f of x minus f of a, f of x minus f of 1, x minus 1. F of x was 4 minus x squared, minus 3, because minus there, x minus 1. That gives me negative x squared. 4 minus 3 is plus 1. Factor out the negative 1. That gives me positive x squared, take away 1. That factors x plus 1, x minus 1. I get a negative there. What? I cannot find that negative sign error. It's in here, but I just don't see it. I'm hopefully not leading you astray here. Hopefully you see it, because clearly that slope is not negative. And over here, when we do equation 2, we don't get a number, we get an expression for the slope. We did this in class. Now, if we wanted to know the actual slope of the tangent line, we would plug in 1. And so we would get 4 minus 2 times 1, or 2, which is the correct answer. I'm still not sure where I made my negative sign mistake over there. It's going to be really, really embarrassing whenever you come to class and explains that to me. All right, so that's question number 3. From there, they ask us to do 7 and 8. All right, 7 and 8. So what are we doing here? Well, I'll work on problem number 8 because it's algebraically a little more daunting than problem number 7. Okay. So I'm sure you noticed when you did the homework, the algebra for these problems, well, it can get a little involved. Question 8 says y equals 2x plus 1 divided by x plus 2. And our point here is 1, 1. And I'm going to use the formula that says m equals, the limit is h goes to 0 of f of x plus h minus f of x all divided by h. So to do this, the first thing I have to do, I'll do it over here to the side, is I'm going to have to find f of x plus h, aren't I? Now, what is that going to be? That's going to be 2 times x plus h plus 1. Here I'm going to have x plus h plus 2. So that's going to get me 2x plus 2h plus 1 divided by x plus h plus 2. F of x, of course, is going to be 2x plus 1 over x plus 2. Now we're going to plug those in. So we're going to get 2x plus 2h plus 1 over x plus h plus 2 minus 2x plus 1 over x plus 2, all divided by h. And we have to take the limit as h goes to 0. That's one of our complex fractions. So we're going to have to get a common denominator. So our common denominator is going to be x plus h plus 2 times x plus 2. Here, we already have 2x plus 2h plus 1. But we're missing, right? We're missing in this denominator, we're missing an x plus 2. We've added it in the denominator, so we're going to have to multiply it by it in the numerator. Minus 2x plus 1, right? We're missing down here x plus h plus 2, so we're going to have to multiply here by x plus h plus 2. And now, of course, all this is divided by h. And as we talked about in class, that h really goes right there. Now, what is this going to look like? Well, we're going to have to multiply. So we're going to have to FOIL. Well, not really FOIL. We're going to have to distribute. X times 2x is 2x squared. X times 2h is plus 2xh. X times 1, well, that's x. 2 times 2x, 4x. 2 times 2h, 4h. 2 times 1, 2. Minus, now let's remember it's minus all of this, right? So I'm going to put a bracket here to make sure that I remember that that negative sign distributes to everything in that product. So this is going to be 2x times x, 2x squared, 2x times h, 2xh, 2x times 2, 4x, 1 times x, x, 1 times h, 1 times 2, 2. Now that all gets divided by, I'm going to go ahead and move that h where it belongs. Now, does any of this cancel? Right? That's our next question. Here's negative 2x squared. Here's positive 2x squared. Here's negative 2xh. Here's positive 2xh. Here's negative 4x. Here's positive 4x. Here's negative x. Here's positive x. Here's a negative h. Here's a 4h. So that's going to leave me 3 h's on the top when I take those into account. Here's a negative 2. Here's a positive 2. So the only thing left in the numerator is 3h. Our denominator stays the same. Remember, we don't multiply denominators together in a calculus class, generally. This h cancels this h. That's always going to happen if we've done our algebra correctly. And we're left with the limit as h goes to 0 of 3 divided by x plus h plus 2 times x plus 2. Now h is going to 0, so this term disappears, and we're left with 3 in the numerator, x plus 2 times x plus 2. How nice is that, right? So that's number 8. 7 works out similarly, but it's a lot nicer, right? You have to rationalize, but it's a lot nicer. So what about 11, 13? Well, problem 11 is a graph. So let's take a look at that one. So problem 11 says, a particle starts moving to the right along a horizontal line. The graph of its position function is shown. When is the particle moving to the right, moving to the left, and standing still? Okay. So, and it says draw a graph of the velocity function. So in problem 11, they give us a graph. And this graph goes from, here's 1, here's 2, 3, 4, 5, and finally 6. It starts at 0, 0. It goes to 1, 3. Right here, so that's 3 tall. So it goes like this. And then it goes at 2, it's still 3. So it goes horizontally. And then it goes down to 1 at 3. So here's 2, here's 1. So it's right here. Then it goes horizontal to 4, right there. Then it goes all the way to 6. It's back up at 3. Okay. That's what it looks like. That's our position function, right? That's S, that's position. This is T, that's time. Now, we knew, based on what they told us in the problem, that our particle is moving along a horizontal line. So we're going to plot where our particle is located along this line. This is position. So at time 0, we're located at position 0 because it's 0, 0. So I'm just going to call this 0 right here. Now what happens? So I'm going to write t equals 0 right there, just so we can see when we're there. Now at time 1, we're at position 3. So we have moved to the right 3, because from 0 to get to position 3, I had to move to the right. So this is 3, and we're here at t equals 1. Now at t equals 2, this is a horizontal line. We haven't changed position. So our particle has been sitting at position 3. It's at position 3, it's at position 3, it's at position 3, it's at position 3. We're still sitting here at t equals 2. We're still at position 3. So from 0 to 1, we went over here like this, right? This is what we did. But then what happens? Well, after we've gone to position 1 and sat there until time 2, at time 2, we back up because we're located at position 1. So at time 2, we back up to position number 1. And that's where we're located at t equals 3. At t equals 3, we're at position 1. That's our position right there. Now at 4, we're still at position 1. So we're still here, t equals 4. But then we move back to position number 3, right? Where we move back from t is 4, we move back to position 3, and we're there at t equals 6. So right here, we were moving right. Right here, we were moving left. And over here, we were moving to the right. Now, it asks us in question number 11, when is the particle moving to the right? Well, from 0 to 1 and from 4 to 6. When is it moving to the left? Well, it's moving to the left from 2 to 3. When is it standing still? 1 to 2 and 3 to 4. Then it says, draw a velocity curve, all right? Draw a velocity curve, graph the velocity of the function. So here's t. This is going to be velocity now. Now we have 1, 2, 3, 4, 5, 6. Now our velocity, we said in class, our velocity is the rate of change of position, the rate of change of position. So our velocity, rate of change of position. Or we said it's the change in position divided by the change in time. Change in position over change in time, that's slope. So our velocity is the slope of each of these curves. So our velocity here between 0 and 1 is the slope of that curve. That's our velocity, the slope of the curve. Well, we know the slope of this curve. It goes from 0, 0 to 1, 3. We know that the change in y is 3. The change y is overrun. The change in x is 1. So from time 0 to 1, our velocity is 3. But then what happens? Well, between time 1 and time 2, the slope of that line is 0. There is no change in position. Change in position is 0. So the slope of that line, that's our change in position over change in time. That turns out to be 0. So there, we're at rest. We said right here, we're at rest. So there, we're down here. Our velocity is going to be 0. Now, what happens between 2 and 3? We're moving to the left, right? We're moving to the left. Our change in x is 1. Our change in y is -2, right? Change in position is -2. Change in time is 1. So our slope is -2. So our velocity, ran out of room on my we'll put it right here, even though the scale's off. Our velocity between 2 and 3 is -2. Between 3 and 4, we stop again, right? We stop again between 3 and 4. And then what happens between 4 and 6? Well, our change in x is 2. Our change in y, we go from 1 to 3, right? 1 to 3. If we were back in algebra 1, we would have written something like this. We would have said, well, the change over here is 2. The change over here is 2. So the slope of that line is going to be positive 1. So our velocity between 4 and 6 is 1. So that's our velocity curve. Now 15 through 21, right? 15 through 21. So I'll just grab a couple of these and see if if we can help ourselves out here. I'm not going to do all of them. So if we look at number 17, all right, 17 says we have a function, right? They draw a function for us here, and our function looks something like this. It comes up and it comes down, and it goes through here, and it goes up, and it goes like this, right? And this is -2. This is -1. This obviously is 0. This is 1 over here. This is 2. And then we have 3. And we have 4. And they ask us questions, right? It says arrange the following numbers in increasing order. Increasing order. 0, g prime of -2, g prime of 0, g prime of 2, and g prime of 4. Now, we're supposed to put them in increasing order, smallest to largest, right? So we're supposed to put the smallest here, and then the largest down here. Increasing order. So we're going to take a look. Now, what are they trying to get us to realize? They're trying to remind us that g prime is the slope of the tangent line. So right here, the slope of the tangent line looks like this. It's very steep and positive. At 0, the slope of the tangent line looks like that, right? That's negative. Goes down to the right, that's negative. At g prime of 2, slope of the tangent line is positive, not as big as this. And g prime of 4, right? The slope of the tangent line here is positive, but not as steep as this and not as steep as this. Remember, they're trying to get you to remember that g prime means slope. So we got to put them from smallest to largest. Well, this is the only negative value. So the smallest value we're going to have is g prime of 0. It's negative. We don't know what it is. It's not important. They just want us to rate them or rank them from smallest to largest. Everybody else, we said this was negative. We said that's positive, that's positive, that's positive. So ranking them smallest to largest, 0 comes next. The smallest positive number we have is the slope here at 4. So that's g prime of 4. Then we have a slope at 2 and a slope at -2. Well, this slope is less steep than that slope, so that comes next, g prime of 2. And finally, the largest number is g prime of -2. So question 17 is about reminding us that, hey, the derivative is the slope of the tangent line. Okay, the derivative is the slope of the tangent line. What about question, I'll do question 20. Well, question 20 says, And it's, it's kind of a word problem where they're going to ask us a question, but they're going to give us enough information to find it. It says at the point 4, 3, right? At 4, 3, the tangent line passes through. So tangent line passes through 0, 2. Find f of 4 and f prime of 4. So if we draw a picture of this, right? We have 4, 3. Here's 4. Here's 3. We have 4, 3. And what do we know? We don't know anything about the graph. But we know the tangent line to that goes through x is 0, y is 2. The tangent line goes through x is 0, y is 2. So somewhere there's a function. We don't know what it looks like, but its curvature right here has a tangent line that passes through there. Now, what do they ask us to find? They've asked us to find the y value that goes along with 4 and the slope of this tangent line. Well, to find the y value that goes along with 4, we already know the y value that goes along with 4. F of 4 is 3, right? They gave us that. F of 4 is 3. But then they want us to find the derivative. Now, we have a formula for the derivative, but they didn't give us any information about the function. So we can't use that. They're trying to get us to think outside the box, not just move symbols. They've told us to find the derivative, but they gave us the tangent line. They give us 2 points. It goes through the point 4, 3, and it goes through the point 0, 2. So we know what the slope of the tangent line is. The slope of the tangent line is the slope of this line. They told us this was the tangent line. So that's the change, not the change in x. That's the change in y, 3 minus 2, over the change in x, 4 minus 0, or 1/4. So this is 1/4. So in problem 20, they're trying to get us to fill in the blanks, right? They're trying to get us to think outside the box. All right, so 29, 30, 33, 34, these are all, well, 29 and 30 are mechanical problems, right? Those are mechanical symbolic manipulation, I like to call those. We move symbols around. So I'll do problem 30. Okay. So what are we doing in problem 30? Problem 30 says find f prime of a, right? That's what problem 30 says. Find f prime of a, and they give us f of x equals x to the -2, i.e. 1 over x squared. And they want us to find f prime of a. And I know that's the limit as h goes to 0 of f of a plus h minus f of a all over h. So I'm going to find a plus h. And we've done this before. This is going to be 1 over a plus h squared. Then I'm going to find f of a. That's 1 over a. And I'm going to plug those in. F of a plus h is 1 over a plus h squared minus 1 over a squared, all divided by h. And there's our friend, the complex fraction. We've seen this before in class, in our notes. We saw we did the homework, and now we're seeing it again now. So we need a common denominator. So what's our common denominator going to be? Well, it's going to be a plus h squared times a squared. On the top, I have a 1. What am I missing here? Well, I don't have an a squared. I have an a plus h squared, but I don't have an a squared. I don't have a factor of a squared. So I'm going to multiply that by a squared minus, here I have a 1. What am I missing? Well, I have an a squared. What I'm missing is my a plus h squared. So I'm going to put that here. Now, we know from previous problems, this h actually goes right there. Right? So when we multiply this out, what are we going to get? We're going to get the limit as h goes to 0. We have a squared, 1 times a squared is a squared, minus 1 times a plus h squared. So that's minus a squared plus 2ah plus h squared. When I FOIL that out, all divided by h, a plus h squared, a squared. What do I have on the top? Well, that's a squared minus a squared. Those cancel. I have left negative, don't forget the negative, don't forget to distribute, 2ah, negative h squared. On the bottom, I have an h, a plus h squared, a squared. I can factor an h out of the top. It's almost like we've been here before. I can even take out a negative h, and I'm left with 2a plus h. On the bottom, I have an h, an a plus h squared, and an a squared. H cancels h. And what are we left? We're left, when we take h to 0, that's gone. So we have negative 2a on the top. H is 0, right? H is 0. So that's a plus 0. That's just a squared. A squared, that's a to the 4th. And when we simplify, we get negative 2 over a cubed. Okay, that's a lot of algebra, right? That's a lot of algebra. Then they give us problems 33, 34, and 37, right? I'll do 34, 33, and 37 are the same. And in this case, they're going to give us this piece and ask us to find this piece and where it's evaluated. They're going to give us the formula for the derivative and ask us to go backwards, right? It's always a sign of understanding if you can go forwards and backwards in a problem. And so in this problem, they're going to ask us to go backwards. So if we look at, again, they asked us to do 33, 34, 37, and 38. So I'll look at 34. Okay. And again, they're all the same. 34 says the limit as h goes to 0. The 4th root of 16 plus h minus 2 over h. Now, this is this. Or if you prefer, you can put an a here. It doesn't make any difference. Now, what do we have to do? Well, we have to find what's my function and what's a. Where am I evaluating this? Okay, now, here's how you do this. All right, you look at this. This function, f of a plus h, is right there. Okay, that's your function. That's f of a plus h. In other words, your function is the 4th root of x, because your function is a 4th root. Now, how do I know if I got it right? Well, we're thinking a is 16, right? That's what we're thinking. We're thinking a is 16 because it's a plus h. This is a right there. We're thinking that's a. But who's this? Well, that's supposed to be f of a. So you have a check, right? There's kind of a built-in check to your problem. You've come up with your function right here, f of x, 4th root, and you just check it. You plug in a, 4th root of 16 is 2, and then you look and go, yep, that's what it's supposed to be, and you're done. That's how you do that. Okay. So what else do we have? We have 42, 47, 49, and 53. All right. So we'll take a look at 49. I'll do 49. So 49 says, at TV, the temperature in Baltimore T hours after midnight on September 26, 2007. The table shows the values of this function recorded every 2 hours. All right. So we have a table, right? And this is number 49. We have a table. And it tells me time and temperature. And 0 hours after midnight, it's 68. 2 hours after midnight, in other words, 2 a.m., it's 65. Temperature's gone down. 4 hours after midnight, temperature 63. 6 hours after midnight, temperature still 63. 8 hours after midnight, 8 a.m. in the morning, the temperature's up to 65. 10 hours after midnight, the temperature's up to 76. 12 hours after midnight, temperature's up to 85. And 14 hours after midnight, 2 p.m. in the afternoon, temperature's up to 91. And it says, what is the meaning of T prime of 10? T prime, what does that mean? Well, we know the temperature at 10 is 76. Right? We have some function here. If we were to graph this function, right, which we're not going to do, but we go from 68 to 65 to 63, then we stay at 63, and then we go to 65, and we go to 76, and we go to 85, and then we go to 91, right? So we have some function for our temperature that looks like this. This is 10 o'clock right here. They want to know, what does T prime of 10 mean, right? This is T over here. This is temperature, little t over here. T prime of 10 is going to be the slope of this line. It's the rate of change of our temperature. Now, we don't have a function. We can't find T prime of 10. And we know we can't find T prime of 10 because in the problem it says, literally the words are, what is the meaning of T prime of 10? We now know what that is. It's the rate of change of the temperature at time 10 a.m. And then it says, estimate its value, right? Estimate. The verb is estimate. The verb is estimate, not find. Estimate its value. So how are we going to estimate the slope? Well, we're going to take the slope of the secant line. We'll take that point and that point, the 2 points that span 10, and we'll find the slope of the secant line. Because we know from first principles, the slope of the secant line is the estimate for the slope of the tangent line. So here we are in problem 49, and they're taking us all the way back to what we learned all the way back in the beginning of slope, beginning of derivatives. So what's the slope of the secant line? Well, we're going to use 12. And we're going to use 8 because they span 10. That's why I picked those. So we go from 85 minus 65, all divided by 12 minus 8. So that's 20 divided by 4, or 5 degrees per hour. Right? That's our units. These are degrees. And these are hours. So at time 10, our temperature is positive. It's positive. So our temperature is increasing at the rate of 5 degrees per hour. Okay, that's a sample of the homework problem. So 2.6. Hopefully that helps you out.